Now, this is a steel structure project that Paul Mohindi, a structural engineering by profession, has created. And in this video, we are diving deep into robot structural analysis. And by the end, you'll know exactly how to build a complete steel frame, just like the one I showed you before, in a step by step way. No guesswork, no confusion, just clear, practical guidance from start to finish. Whether you are a structural engineering student, a budding designer, or someone looking to master robot structure for real world projects, this tutorial is a golden ticket. And the best part, we are not just covering theory. You'll follow along as our expert instructor builds the entire structure live on screen, explaining each move with clarity. So grab your coffee, fire up robots structure software, and get ready to level up your skill.
So the first thing that we're going to do, we're going to run our RSA software, and in this case, we're using version 2024. So once it is started, you need to specify your specific template. So we're going to be working with the Frame 3D design, so you can find it here. Alternatively, you can navigate to new and you'll find the same option under this item. So I'll just simply click on it once. Once it has started, the first thing that you need to do is to define your job preferences. And if you don't know how to set up your new drawing, kindly check down in the description. I've linked a completely detailed YouTube video on how we set up our specific settings for a new drawing. So I'll just simply go to Tools, go to Job Preferences, and specify everything that I need. So under Units and Formats, if I use Imperial, I'll just simply click on this, then click on yes, and everything will be changed to Imperial. But in this case, I am using metric. So by default, it's already saved in metric. So I'll just simply go to dimensions. This is everything that I have. And under materials, this is the most important part. I'm going to change from British to Euro. So I'll just simply click on Eurocode, and we'll clearly see that our elements or our basic set has updated. And this is the most important thing for now. We want to focus with our steel. And for this case, the material will be S275. The next thing will be under database. So I want to change this to Euro. So I'll click on this plus, and then I'll navigate to steel, and I want to bring in Euro. So this is timber, but I want to bring Euro for all sets. So I'll click on this drop down, navigate where we have Euro, then click on OK. And if I scroll down, I'll find now the option has been added. I'll just click on this arrow just to bring it all the way up. The next item that we just want to look at is our standard load. So I'll click on this. We can clearly see that you're working with Eurocode 1. That's all right. And I'll just now check my design codes. So if I click on here, I'll find this basic summary, and I want to update my steel aluminum structure from BSEN to just Euro. So how to do that? I'll just simply click on this drop down, click on more, and then just scroll through my list and search for Euro. So I'll just simply click on this Euro 2005/2014, then click on this icon just to bring it on this side, click as set as current, then click on OK, and all the rest will be updated. If I want more information, I can click on this ellipse, and I'll find all the information about this specific Eurocode 3 defined here. So I'll click on close. And for this other item, let's say for the RST structure, I'm not focusing on this, but I can just update it to be Eurocode 2. And that's mainly it. All these other items, they are all right. We are trying to focus on steel. So I'll just save this as a specific template. Then I'll save it to my folder where I want to use it. And in this case, I'll save it as steel sosca.cov for job preference. I'll just click on save. And if I want to navigate or access it first in future, I'll find it here. After that's done, I'll just simply click on OK. I'll have this warning that if I had set the code to be BS-EN, that is going to be updated to EN 1993. That's okay. I'll just simply click on yes, and that's it. The next thing that we want to look at is the most important part, how to set up our Frame 3D design. So to do that, we simply use an add-in, which is found within Robot Structural Analysis. So I'll click on add-ins, and I'll find this option being the second option, which is Frame Generator. I'll click on it once, and this pop-up window will be shown. So from here, we have so many other commands. And the first line here, we have file, where you can be able to open old documents that you had already saved. So if I click on open, you can find documents that you had saved in rx data and they're saved in .rxd. But for our case, I don't have, so I'll just simply click on close. And if you want to save what you have already worked on, you just click on save and you can define where you want to save, or you can also save as. And if you want to close away, you can just simply click on close and this specific pop-up or add-in will be closed. Additionally, if you want to run your calculation, you can click on calculate here, but the same option is still found down here, which we'll get to in a few. And if you want help when working within this area, you can click on this option or click on F1 on your keyboard. Moreover, we have this column that has various types of tabs. The first one being general, then structure, then loads, then results. Under general, we have two main options. The first one is setting our base, where we have these commands under it. So these commands are simply used to define our specific frame that we're going to generate using this frame generator add-in, and then it's going to be brought back into our model for further analysis and also checks, and after that we can be able to send it to Revit. So under base, we can specify the number of bays. And how to do that? We have this management of bays, where if you want to add, you just simply click on add and it's going to be added. You have noticed after we have added that there has been a change on this side, mainly on these two windows. So the first window is simply where you have your elevation view, and if you click on it, it's going to update in real time and you can clearly see that the colors are changing. The second window is where we have this model view. So to pan, you just simply hold down your left mouse button so that you can be able to pan like so. And the third window is simply a schematic that does not change, but just simply shows you the different connotations or annotations with their meanings within the program. So if I was to select on bay 1, it's going to simply change within these two windows that we have here. So after doing that, we can clearly see that we have some columns here. The first one is just simply a number. So this is a number that is being used, number 1, number 2. And the one that is selected is red in color, and you can clearly see that it's changing over here. So bay 1 and bay 2 are basically the same. So I can just simply navigate to bay 2, identical to bay 1. So that I just have to define the parameters for bay 1 because they're simply the same with bay 2. Additionally, down here, we have the structure dimensions where we have n. So n is basically the number of frames that we have. So over here, we have 5 frames and I'm just going to leave it at 5. And if you try to go with 0, we simply have this warning. It cannot accept. So I'll just simply go with 5. The least that you can go with is simply 2. So if you input 2, it will accept. If you try to input anything like 1 or 0, it's not going to accept. But for our case, we'll go with 5. And the next item is about the spacing of the frames, where we have D. So D is basically the distance from the first frame to the last frame. Remember, the frame is different with the bay, where the bay are simply this entire structure or this entire model. So the dB is simply the distance between each specific frame within this entire area. So in this case, I want to go with 5 just to make it equal. So this is for equal spacing, but if you want it to be different spacing, you use this and you can define, let's say something like 10, and it's going to update the overall length equally over here. So I'll just simply go back here, update this to 20, and also update this to 5, but automatically it's going to pick up. The next item is about the project. This simply means where the specific frame is going to be placed inside our model once you bring it in. So I just wanted to leave it at origin, which is 000, and you can clearly see this. The next item is about specifying your materials. So you can specify all your materials at once, or you can check on this option if you want to specify one by one. Let's say if you want to specify column to be that, and then this one to be that, you can specify from here. But I want it just all of them to be S275, and I just want to specify one material for all of them. The next row is about structure, and under this we have geometry. So under geometry, we can simply define each and every single component of our model, let's say the width, the height, so on and so forth. So if I go back to bay 1, we'll have this option of inputting data, but under bay 2, it's grayed out because remember, we said that bay 2 is a mirror or a copy of bay 1. That's why we don't have an option under this. So I'll just simply click on bay 1, And under this, I can specify the roof type. If I want to go with a single pitched roof, I'll check on this. It's going to update here. If I want to go with gable roof, which is simply this one over here with an apex, I'll simply check on this. And if I want it to be symmetrical on the right hand side and the left hand side, if I check on this, these options will be grayed out. This is simply height CR depicting right, height CL depicting left, and the same options can be seen here. So this is annotation, left hand side, right hand side. So if we specify the height of the roof, we can just simply specify what is the height from this point to the highest point of the roof. You can specify here what is the height of the left hand side from the top of the foundation all the way to where the roof is starting, and also what is the height of the floor from where the foundation is starting all the way to the floor. So this is simply it, and also the width of the specific bay, so from this point all the way here. Moreover, you can also specify your supports by navigating to this option. If it's a pin support, is a fixed support, you can specify from here. And remember, because it's symmetrical, if I check on this, all these other options will be borrowed from this other side. And under columns, you can specify your section. If you want to go with a section, let's say an IEP E100 or something of the sort, you can specify from here. So let's say we go with something like 180 over here. It's going to be married over to this other side. The material, remember, we are working with S275. For the beams, let's go with something like UB, or if it's not here, just simply click on more, and under this option you can specify the specific one that you want. So all that you have to do, depending on the type of beam that you want, you can just simply click on family. So if you want to go with, let's say an IPE also for the beam, and you want let's say a different size, so this is just simply the label, but the section shape you can specify from here. So let's say we want to go with 200. I'll just simply select on that, click on add, and it will be added on this list here. So I can now find it, and I'll just simply select it, and it's going to be married on this other side. Remember, if you want to change also bay 2, all you have to do is to click on bay parameters, edit, and you'll be able to edit. But for our case, I just want them to be identically the same. The next item is about the truss. So this is basically the truss system supporting the roof. So you can just simply go with this simple truss, or you can even go more complex and define also your height of your truss, and also your horizontal and your vertical members and diagonal members, so on and so forth. But for this case, I'll just keep it simple. I'll just simply go with this option, and all these other options will be grayed out because it's just simply a member supporting the roof. The next item is about the deck slabs. So in the event that, let's say we want to place an office, we can specify, let's say we want to place it on the left hand side. We can clearly see that it has been added here, not only just in one bay, because it's mirrored or symmetrical or identical to the other, it's also added on this other side. So we can specify the HSL, which depicts the left, which is basically the height from the top of the foundation all the way to the top of the slab. So if it's 2.8 meters, which is a breadth of the specific slab. So this is basically from the column all the way to the center of this other column that is supporting the specific slab. You can also specify the HSF, which is basically just the height from the floor to this specific foundation. So for our case, I'll just leave this as is. We can also specify the type of decking material used for our beam. So from here, you can change the section. If you want to go with something smaller or something like 140, I'll specify over here. For the columns also, I can just specify over here. So this is a small column that we have here. I can go with, say, something like, I can just leave 160, that's okay. The type of support again. And I can also specify the decking material for our slab. So I'll check on slab. If I want to go with concrete, I can just simply specify over here. If I want to go even further and specify more information or create a new specific thickness, let's say I go with 150 and also specify the thickness being 150, the concrete being this. All I have to do is just click and add. It's going to be added here, and I'll just simply select it over here. So that's the way we specify our slabs decking. The next item is about the eaves and the attics. So this is simply where we're going to have these extensions. So if I check on, let's say I want it on the left hand side, let's say to prevent the water is going to be brought in over here. And remember, because it's symmetrical, whatever I'm checking here is being done on this other side. But for this case, I'm not gonna be using this, so I'll just simply uncheck and it's gonna be removed. The next item is about the brackets. So if I want the brackets for the joints, let's say the column, the beam, the apex, so on and so forth, I can specify over here. The next item is about the purlin. This is simply what is gonna be holding our roof. So we can specify, let's say, the number of purlins. So this is the number of purlins, which is basically these horizontal members that are moving perpendicular to this other base. Alternatively, you can use the purlin spacing, which is the DPL, which you can clearly see here. In between each specific purlin, what will be the distance? So this is usually guided by the type of sheet that you're going to be using to install your roof. The PRL, which is simply the distance from this point here, which is a rafter, to the specific purlin, and also the PCL, which is a distance from this column to this specific purlin. And the same thing is repeated on this other side. So I'll just leave it as is. You can also specify the type of purlins, if it's a single purlin or a continuous purlin. For our case, I want it to be a single purlin, and you can also specify the material being used for purlin. So we can go with 100, the material still being the same. You can also specify the roof rigid beam. So over here, I'll just simply go with 140. I'll just leave it as is. And you can specify if you want the start to be on the left hand side and the right hand side. The next item is about the bracing. So this is a bracing system, and you can specify. So for our case, we just have for bay 1 having the bracing system, but let's also add for bay 4. So you just simply click on this drop down. I can click on this and it's gonna be updated here as well. So this is for the left wall. So over here, so let's update for the roof. Let's go with this, the same option here, and also the right wall will be the same. So we can clearly see that it's been updated here in real time. Remember, whatever we're doing for bay 1, it's also happening for bay 2 because they're just simply symmetrical. So the next thing is about the dimensions. So this is basically the HWC, which is the height from this point of our column or where the bracing is starting up to where it's been connected. The next item is about the wall bracing. So you can specify the material that you're going to be using. So I'll just leave it as is for this demonstration, as well as the roofing bracing. If you want to add your outer walls, you can specify here. So what type of outer wall are you going with? Is it this type or these other types? There are so many options. So let's say we go with something of the sort. You're going to have here, you can define all these parameters and it's going to be okay. Then last item before our calculations is about the loading. I'll click on loading, and under here we can define our dead loads. So all I have to do is to check on this. Let's say we go with something like 2.5. And our live loads, we can go, let's say if this is a warehouse, you have to refer to Eurocode. So I'll go, let's say with something like 4. And you can also specify your slab loads. So this is 20 kilonewtons per square meter. The live loads being 20 per square meter. So this is just simply what you can define. And also you can define your crane loads. So if you're working with a crane or anticipating that you're going to be having a crane in your structure, you can specify over here. So what is a HM, which is basically the height from this top of foundation up to where we're going to have this specific member or where our crane is going to be installed, and what is the length from the main column up to that specific railing of our crane. So you can specify from here as well. So I'm just leaving everything as is for now. And if we have also to define our snow or wind loads, all I have to do is to check on this, navigate to settings, and define all the parameters for my snow and wind area. So if my speed is something like this, let's say I go with 21.5, I specify the snow zone, let's say zone 3, I specify the altitude above the sea level, reason being this has a big correlation with the wind speed. So let's say we go with, let's say with something like 2000. If I specify the structure age, if I'm designing for, let's say 50 years, I'll define over here. And if I want to define, let's say the angle at which the wind is hitting our building, I can define over here, so on and so forth. So you can define for all members as an envelope or specific member list. So I'll just go with all members, something of the sort. And you can even go even further. Let's say the wind, you can specify more about it over here, specifying even the terrain type. You can specify for the snow, going even further, and also for the permeability, going even further. Let's say if you have openings, so on and so forth. So for our case, I'll just simply click on close. Then I'll simply navigate to the last item, which is about the results. So under results, we have two main options, bin documentation and calculation design. So before we get documentations, we obviously need to do the calculation. So all we have to do is click on run. But before that, I'll just simply save this specific settings that we have gone through. So I'll go to file, then I'll click on save and specify the folder that I want to save. So after you save it, it's going to be shown like this. So framegenerator.rxd, or depending with the name that you have given it. So you can go through the service limit states parameters over here if you want to change, but for this case I'm just going to leave it as is, and also the calculation options I'll just leave it as is, and then I'll simply click on run. So I need first to save the changes on my structure, so I'll click on yes. So there's saving these specific inputs and then saving the information about our structure. So I'll just simply navigate to the folder that I want to save it. So in this folder, I can just call it, let's say, like steel frame 3D. Then I'll just simply leave it as robot.rtd, then click on save. After that's done, our robot structural analysis is now running the calculations and also going through all the parameters that we have inputted. So after a few minutes, it will be done, and you'll clearly see that in the background, we have something looking beautiful. So it's just simply a model. And we can clearly see that we have just one warning, which is not an issue, which simply says that there's a duplicate load case label, but that's not an issue. So under documentation, if we now check on note, and we can get now the simplified note, we can have a preview, or we can even open it in a Word document. So I'll click on Word, then I'll click on OK. So it's gonna tell me to save again. So I'll just simply click on yes, just to save it again. And I can just say this like analyzed, then click on save. So you'll see that in the background, the documentation is being done. So we have our tables down here, and it's simply running. We're at 95%. This can actually take some time. So it's important for you just to be patient, just to get all this data. So after that's done, you're going to just simply have this pop-up in your browser, which is just simply all the breakdown of the analysis and the results that have been done within your project. So it's quite a lengthy detail where you can see if there's any issue and if the sections are passed, so on and so forth. Back in Robot, so this will be the display of our structure, and right now we're using, or by default usually uses, marked by color by members. And we have ginormous members here. So you can just simply select, right click, select similar, let's say by cross section. And then under here, under sections, all you have to do is just simply go to this drop down, click on this tree, and you can specify, let's say, a smaller type of section. So if I just simply select on this, it's going to simply change our results, but that's simply how you do it. So you can also close, hold down your shift key just to be able to orbit around. And so far so good. It looks really good. So that's simply how we do it. All right, so that being said, the last thing that just simply remains is just to send our specific model to Revit so that we can be able to get more detail. Let's say do some annotations, so on and so forth. So you just simply run your Revit software. So the first thing that you do in your Revit software, in this case, you're using Revit 2024. I'll just click on new, and I want to work with a structural template. So I'll click on structural, I'll click on open. And right now it's just simply open and creating our project using that template that we had. So I'll just simply use my Windows key and direction key so that I can have my Revit software side by side with my robot software. So like that, and also robot on this other end. Once that's done, I'll just simply navigate to add-in, then I'll just navigate to integration, then click on Autodesk Revit. I'll have this pop-up window, so I want to send the model and the results because you already have the results in robot, and using the direct integration and under sending options. And once that's done, I'll just simply click on OK. So I can give the name of, let's say, this structural package. For reinforcement, we don't have, so I'll uncheck that, and then I'll click on OK. So it's just going to take a few seconds just to send into Revit. So inside Revit, I can click on perspective so that we can see how it looks like once it is brought in. So once that's done, you're going to have this events report. So you can just click on yes if you want to see it. So these are the warnings. So there are some load types that are not supported in the transfer. That's not an issue. I'll just click on close. But on this other side in Revit, we can clearly see how beautiful it looks like. So we can clearly see that these are just our loads. These are wind loads being shown. If I don't want to see it, I'll right click. Then I'll just hide in element by category. So this is how our members look like. So somebody might ask, how do you then get your members? Because all these are just analytical components, but where exactly is or are our members within this specific Revit? So if you click on this member, you just simply see that it's an analytical model and we do not have any members or physical members in our specific model. So how do we get our physical members? It's quite simple. Right now, I'll just maximize this. I'll just simply jump to manage, and under manage tab, we'll have this visual programming tab where I'll click on Dynamo Player. So this window has a couple of items that you can be able to use to come up with the specific items that you want. But interestingly enough, we cannot find exactly what we need to generate our physical members. So you just simply click on this add button. Then you're going to navigate to the specific folder that has that specific information. In for our case, is this analytical automation. So I'll click on select folder. But for your case, it's just simply located under the specific directory that you have saved. So local disk C, document data, Autodesk, Revit 2023 for this case. So this is 24, but this is 23. It does not really matter. And then we have Dynamo because I already have Revit 23, but for your case, you have to specify 24. Then you have Dynamo, then samples, then ES, and etc. But if I wanted to change this because I still have 24 and then hit an enter, I'll still be navigated to Revit 24. Then I'll just simply click on select folder. It will be added here. I'll click on OK. And from here, I'll just try to look for my newly added items by clicking on this drop down, click on analytical automation, and then we'll find this option of analytical to physical for buildings. So I'll click on this option for play. Then this pop-up window will be shown where simply I need to put the input so that we can generate the physical elements for our project. So the first item is to select. The second one is to update the geometries of the associated physical elements. I want it to be true. The next one is the parameters of the physical elements. I want it to be true. And to preserve the joint settings for the associated physical elements, I want it to be true. And also generate the default joints between the elements. So I want it to be true. And I want also to create any walls or floors. For our case, we have this floor here, so I want it to be true. After that, this is about output. So let's select. So I'll click on select. Then I'll use my dash selection from right to left. So I'll make sure everything is selected. Then I'll just simply go back to my player. We're going to have this list here, but it's just simply the IDs. After that, all I have to do is just simply click on run. And right now it's running, just simply coming up with a specific physical members, and you can clearly see that they are there. So this is the output. This is just simply a list or a summary of all the members that have been made. Also the part or the member type that has been created. We can clearly see over here the name. This is okay. Then I'll just simply click on back, then click on close. So that's simply how we do it. And if I orbit, we can clearly see this is exactly what we had in RSA. So I'll put these two items side by side like so. Alright, so that's it for today's tutorial on designing a complete steel frame in robot structural analysis, then exporting it to Revit.
So that was all about making a structural engineering project in robots structure. But this is just the tip of the iceberg. If you want to learn the real deal, then sign up for the free Robots Structure Essentials course. Link is in the description of this video. And let me know in the comments down below what you want to see in the next video. I'll see you in the next one.